Welcome to the second day of Tech Ed, beautiful Atlanta, Georgia. This session is about writing an MVC view engine, but you already know that, you're here. And my name is Louis DeJardin. I work at Microsoft on the team in ASP.NET that's creating the Orchard CMS. And before joining Microsoft, I wrote the Spark view engine, which is a third-party view engine available for download for free for the ASP.NET MVC platform. The view engines in MVC are basically a great extensibility point. They enable you to create a new DSL if you want to. The MVC came with web forms as a view engine from the very first version. And later on, they included in the box a Razor, which is a new view engine that was created fairly recently. Those are only two of the possibilities. There are others that you can download, and you can also use this extensibility point not only to create your own templates, but also to take control of the rendering process. That's why I call it an extensibility point. A lot of the controllers in your application will return view or partial view. All of those return values go through the view engine extensibility point, enabling you to participate in that rendering and participate in the rendering of things that call HTML partial. We'll take a look at that later. That opens up interesting possibilities where you can consider exposing some of your APIs even as things that look like you're rendering partials. You don't need to ship templates if you have a view engine which understands those partial names and can render them. That said, this is kind of an advanced topic in that it assumes that you have complete familiarity with the MVC pattern and a lot of the programming concepts inside of it. And some of the nuts and bolts can be a little bit detailed in the middle of it. We're going to be talking about the appropriate use of caching and the use cache. And taking a look at some of those can kind of make for a bit of a drawn-out bits here and there. There are also several stable production-ready options available, and the ones that are built in are fantastic. And this is often not the simplest approach. And what I mean by that is, well, for example, taking a look at this ad system implemented as a custom view engine, you could just as easily imagine that this could be an HTML helper. The net effect is the same, and it could be simpler. That said, it's a very good tool to have in your toolbox so that you can turn to if you see a situation where you want to take advantage of this extensibility point. And it's good to know how, and how to do it correctly. So, rewinding a little bit, where does this fit in? In MVC, of course, the controller builds the model, which is drawing the information from all of the places where it exists, databases, web services, etc., and it passes that to a view for rendering. Not every action returns a view, but most of them do. When you return a view, control comes back to the MVC framework, and it will, in turn, go to the list of registered view engines and ask them to decide which of them is the best view engine for rendering this view. There's a process that they kind of collaborate with each other to make sure that the view result is the appropriate one. And like I said, there are many well-known view engines. There are several third-party ones, and they should all be built to work together seamlessly. So it's not like you're making a choice. You're not giving up the built-in ones if you decide to build your own or add additional ones. The built-in ones implement this API, the same ones that you use to create a custom view engine. And the entire API that you need, the entire surface area of a custom view engine fits on one slide. It starts with a view engine interface who has a fairly simple responsibility. It finds a view, or it finds a partial view. It has the option of doing some housekeeping when the view is no longer needed if you want to put code in release view. But the only other significant thing you need to implement is the view itself, which has a single method render. In order for your view engine to be visible to the system, you would add it to the third and final concern, which is the view engines collection. This is a similar pattern that you find in other places in MVC, The route table works the same way. The data binding models work the same way. There's a singleton collection you can access and add things to. All right? So with all that said, let's jump right into the first demo where we create a view engine with the least amount of code possible. Starting with a vanilla MVC application. We'll create that now and call it Claymore Demo. All right, and defaults are good. So that's building. And we have a vanilla MVC application. To hold our view engine, we're going to put that in a different project. And that's going to be a simple class library. This isn't a special project type. It's just normal classes. We'll call that Claymore. And the first thing we're going to do is get rid of this, the least useful class in the history of computer science, class 1. We'll rename that to Claymore View Engine. The only thing special about this is that it implements iViewEngine. Whoops. Add the reference automatically, and we will implement the members, the 3 that we talked about. The least that you need to do to be correct is, well, nothing for release, and to return a result which sort of denies knowledge of the request. The request is going to come into you with all of the information you need to find the view that's needed, in particular the partial view name. Or if you're finding a view, it's the view name and the layout, which is null or empty for the default, or this will have an actual value if you've passed in the layout in your return view. So when we return a new view engine result, we can return an array of no strings. This result essentially means that we didn't find anything. When you return an array of strings, you're saying you didn't find anything, and we're also saying we didn't look anywhere. We'll return this from the other view as well. So now we have implemented a view engine that does nothing. To make it a little bit more interesting, let's recognize one of the partial view names and return a view that returns some HTML. If partial view name is about Claymore, return new view engine result. And here we're going to use the second overload, where we return something that implements iView, and we return a reference to ourselves. New, about Claymore, this. So just starting off, we can implement this as render, writer, write. Paragraph, and we'll just say Claymore, version 0.1. Okay. So in the call to render, we see that we're given more context and a writer. Interestingly, we don't really want to write to this writer. We'll see that later. So let's build and run. So after a few moments, we should see the familiar MVC blue default application. Interesting side note, I work with one of the designers who originally came up with this, the sort of like CSS and theme. So it's interesting, working at Microsoft sometimes you see some interesting history around. All right, so we can go into our view that we were just looking at. And let's render HTML partial, a view, the partial view about Claymore. Okay? And we should see an error because the MVC framework doesn't know about our view engine yet. That's the only piece of code that's missing. And we can add that simply as a additional startup thing. View engines, dot engines, add, and it's simply a new instance of a class. Recompile. And success. So here's the output that we have from our new custom view engine. And you'll see that Razor, which is putting out all of this HTML, is still in effect and is coexisting peacefully with our custom view engine we have just created and added to our system. All right. So that is the least amount of code that you need to create a view engine. It is not very interesting, and it's also buggy because there are a few things that we're not doing correctly to work well with the other view engines. Well, one of the things you notice is that when the error came up, it was only showing the other two view engines. We could augment that error message, which is one of the best error messages that comes out of MVC because it tells you exactly what was wrong and what you can do about it, where you could put files and what extensions they could have. The other problem that we're currently experiencing is that the order that the view engines are registered is important. When you add a view engine, it's going at the tail. It's going at the end of the list. If there was a file about claymore.cshtml that was Razor, Razor is in front of us in the list. It's at the 0 or 1 index. It should render that view and not our engine. To make sure that happens, you have to pay close attention to the use cache boolean that's passed in. The reason for that is when the MVC framework is talking to the view engines, it's going to go through two passes. So on the first time find partial view or find view is called, it goes through each view engine first with use cache being true. If you have not seen that request before, you should not return anything. It then goes through every view engine with use cache being set to false. If you only return views when use cache is false, you'll be implemented correctly. You don't have to worry about the case when use cache is true. If you do want to optimize the performance and not hit the disk every time to make sure that the view is there, you can remember when the parameters to partial view or to a find view are the same. Remember when the parameters to it are the same, and then return the same result the second time. In this example, we can see that the view engine at index 1 has recognized that it is responsible for the view the first time when use cache is false. And then the second time through, when the parameters are identical, it's going to return results on the first loop through when use cache is true. So, hopefully that makes sense. The reason that this can introduce problems, and the reason I say that our Claymore view engine is buggy right now, is because we're not even checking use cache. The about Claymore will return on the first pass, denying the other view engines a chance to even look for it. This will happen in the first time find partial is called, and every time after that. We're sort of cutting ahead in line and returning a response, even though we've never cached it, we've never seen it before. We're just returning it flat out. So let's take a look at what is involved to fix this, and also to implement caching and custom errors appropriately. We can do that jumping back into our Claymore view engine. The simplest thing, like we said, is to say if use cache is true, then don't do anything. Deny all knowledge of that request's existence. And we can do the same on the second call. For the purposes of this demo, we're going to be taking a look mostly at the find partial view. Implementing find view itself is essentially the same patterns, but I'm just not going to cut and paste code every single time between them. The second thing we're going to want to do is to have a new list of string for our search locations. These are the places that we looked, and we'll return that now. These are the places we looked, and we will return that when we're essentially not returning a view. All view engines, if they all fail, MVC will concatenate them together and throw that as the final result. To see an example of that, we can add what is basically just any old format. Claymore, 0, and the partial view name. All right. So we can compile. Coming back here, we work the same. And by adding a reference to a missing view, hello, we will get our Claymore location mixed in with the rest of the view locations. Most view engines will use template files, and they'll express their possible locations in terms of a virtual directory, virtual path. But that's not strictly necessary. You can implement your algorithm any way you want to and imply it back to the user in any way that seems appropriate. So although we're now correctly handling the use cache Boolean, we are not doing any caching. If you do want to do caching, like I kind of alluded to before, what you want to do is cache based on the parameters that come in, and you're going to cache the result of your search algorithm going out. To see what that distinction means, we will add a dictionary. So we'll add a dictionary, and we'll type def our cache key as a tuple. So what we have here is we're taking the various input parameters and treating them as a tuple because a tuple is a convenient thing that can go into any dictionary key. And we're going to remember, based on the parameters that went into the request, here is the work we performed. So we're going to cache a function. We're also providing a couple of nice utility methods for ourselves to store and recall. They'll look very tight in the code when we add them. Let's add them now. So if use cache is in effect, we are going to return what we recall as far as our key goes. And our key is going to be an instance of the material that makes us unique. Partial view name. The other thing that we're going to say makes us unique is the controller name, which exists in the controller context. Under route data and get required string. So this is the best way I know of getting strings that are, well, it'll throw an exception if it's not there. It's basically assumed that everything is going to have a controller name. And in our tuple, we will return a true. Oh, it doesn't resolve that. Let's try tuple. There you go. The third argument in our tuple is true. We'll just use true for the partial views and false for the full views, just so that our dictionary is distinct between the two cases. This is it. We have just implemented the caching side of it for when the request comes through the second time, and we can hit our material that we've saved and re-execute it. Let's turn back to this code and store the fact that we've hit our About Claymore view. Store, key, and like I mentioned, we're storing a function. So a function such that we're returning a new view engine of About Claymore. Okay, let's go back to our index and remove our error. And to verify that the cache is working as expected, we'll set a breakpoint on this function to see when it's being called. And F5 to run. Our breakpoint is hit, and we can see in the call stack, find partial view was called, and we called through our store method. And this is the anonymous function that store is calling back before it returns. We can also see that use cache is false, so we are in the second pass. Continue running, and here's our results. Refresh the page. We've hit our function again, but there is a difference in the call stack. We did call find partial view, but now this is in the call through to our utility method recall, which is hitting our function to return a result. So in recall, it's essentially looking in this dictionary to see if there is this factory that's been cached before, and if so, it's invoking it. And that recall is being called when use cache is true. So it's a convenient way of doing like a functional cache. We're not worried about what the virtual directory is. We're not worried about complex pre and post conditions. We're basically saying that for the inputs that will make this algorithm vary, here is the result that you need to execute. Here is the function you need to execute. All right. So we've covered the basics. We've covered how to extend the error message. We've covered how to properly implement caching. None of this is interesting so far, because the only thing we've really accomplished is we've written a class that created some HTML by returning a string. What view engines typically do is they're based on template files with a mix of HTML and code, and they have their own spin on what is a most useful for their domain. What sort of approach feels right for them? Like there's the Razor and web forms in MVC are an option, and they're good ones. Web forms is time tested. Razor is tighter, cleaner. There are third-party view engines also, and Haml is an interesting one that has a DSL that even makes the HTML less redundant. It reduces the closing tags, and it uses indentation to imply when the closing tags occur. We won't really be taking a look at that today. I just thought it was interesting, worth mentioning. Most of them, though, have an approach inspired by literal HTML. The fact, though, is that they're usually based on template files. So that's what we're going to take a look at next, is taking an existing transformation engine, which isn't an MVC view engine, but can take the contents of a file and turn it into HTML. And we're going to build that into our Claymore view engine next. So this is where we start to bring files into the picture. To avoid making this view engine class itself become larger and unwieldy, we're going to put the file access, for the file system access concern, into its own class, named creatively file system. And rather than write this out, we're just going to use a copy of a file system accessor that already exists. So for this to work for our needs, we're going to have this do two things. It's going to take a virtual path, and it's going to take an action to call back. The two things that it's going to do are to monitor this path for changes and call back our action when that path does change. The second thing that we're going to have it do is load the contents at that virtual path and return them to us, basically by going through the virtual path provider. We're going to return null if we don't exist for any reason or have an error loading. And the cache itself, this is interesting because in medium trust, you can't really use a file monitor. So one of the tricks that you can use is to create a cache dependency based on a virtual file path. We're doing that here. If you create a cache dependency based on a virtual file path, you can add that as a cache entry. So we're adding a cache entry that we're making up a unique nonce and making it dependent on this virtual path provider. This entry that we're adding itself won't expire on its own, but if it does change and expire because this path changes, we're asking ASP.NET to call us back. And when this is called back, we're going to invoke the changed action. So does that make sense? We're basically implementing the monitor here by saying when this virtual path changes, we're going to do this, which will cause the action to be monitored without using file monitor, which is not allowed in partial trust. All of that said, it basically boils down to being able to load and monitor a file. All right. So let's use that in here, starting with a list of possible locations. IEnumerable of string. Spelling. There we go. And for the possible locations, you may be familiar with the standard view engines have a public property that give you a format string that you can modify. This is where that comes into play. This is where you would iterate through your formats and use your key material to expand them into all the different locations you may exist. So let's pass in cache key. Rather than do that, we'll just return some just hard-coded formats. Looking first in views 0.1.md. If you recall, our tuple had the view name and the controller name as the first two parameters, which also means that this needs to be this way. And we can also look in shared. Now we'll iterate over this. For each of the possible locations, given the key material that we've already acquired, well, we're definitely going to want to inform the user that this could have been a place they put a file. By adding the possible location to the search locations. And now we'll exercise our file system. So finding the possible location and doing nothing for the time being. The text goes here. if the text is not null, here's where we're going to do our work. We've hit a file, it had the extension that we were looking for, and we are going to transform that text. And we are going to transform that with a Markdown library. So Markdown Deep is one that is available off of NuGet, and we want to add the dependency to the Claymore class library. Press enter there. All right. So we'll have a new instance of that engine. Transform from text to HTML. And now that we've done the busy work, we will return our stored functional result. We're going to make a new instance of a class, Markdown View, and pass it the HTML. And this is just going to be another simple small class. All right, so have we covered everything? Oh, there is one thing missing. When this change occurs. So one of the interesting things about using a closure is that this will close over this variable, so the transformation will only occur once. The problem is that if we change the file, the closure won't be updated. We'll still get the same results written out every single time, even though the file is changed repeatedly. To make that not happen, let's wire this call back up. We'll give ourselves the ability to forget by saying what the key is and removing it from the cache. And then when this function gets called, we will forget whatever we did to create that view. All right. So now we have integrated a file system and utilized it. In our index view, we can uncomment our hello partial and see that our error now is telling us the different places that we could put a Markdown file. Let's use one of those locations. A simple text file will do. And some Markdown text. Interesting. You know, to be honest, I don't know why this is not working. What's that? Views home? Oh, I'm in the wrong folder? No, that should work. Oh, there it goes. I have no idea why that didn't work the first few times. I must have had to hit compile. Are we seeing changes? Okay, now that's peculiar. It's a little concerning, but it seems to be working, so we'll just run with it. So we now have a view engine that will understand its own type of extension, and we can mix and match our view engine with the standard ones. And it is using an existing engine for its actual templating. So we didn't even have to write the Markdown interpreter. Some of the view engines are actually written this way. NVelocity, for example, is based off of a velocity transformation library, which exists outside of the MVC view engine. All right. So far, we've transformed Markdown into HTML. But that Markdown is fairly static. There's no way to put code in there. And if you did have code in there, there's no way for it to access the fundamentals. All of the razors and the web forms that you're going to use give you access to output HTML helpers with HTML.partial, as we saw, HTML.textbox, all of those types of things. They also have access to the view data dictionary, view context, and output methods let you write things. The reason this works is because those are generated as classes, which subclass a base that has those as public properties. When you are touching HTML dot, what you're doing is using an HTML public property on a base class of the generated class for that view. To make that happen, you're essentially going to want a proper base class in your view engine library that implements iView and has all of these properties populated when the view starts to render so that they can be used by the generated function. So let's write our base view class. Jumping back over here, we will start with a public abstract class. Call it Claymore View. And when we implement members this time, we're going to make this a private explicit. This is not something we expect people to override or execute directly. The two things that are going to happen in this function is it's going to contextualize the class, contextualize the instance of this view, and then call an execute function that will be overridden by the descendant. Contextualize, passing the view context, and then execute. So, protected abstract, void for the execute. There's no implementation. This needs to be provided by the generated class above us. But contextualize is going to be more straightforward. It's basically going to set a lot of properties. The properties are the ones that we discussed just a little bit ago on the previous slide. View context, the view data, if there's going to be the HTML helpers, those types of things are all going to need to be populated by contextualize. And we'll pass this as an argument. And these helpers are actually simple classes that can be created. The only thing they take is the view context and an iView data container. This is one of the things that, if I tried to explain why there's an iView data container interface, I don't think that I don't know why. So I wouldn't be able to explain it properly. It's just one of the things that you implement and you don't worry about. So let's implement that on this class. So our view is now an iView data container, which essentially means that it has a view data dictionary. The helpers get at the current view data through this iView data container. All right, fairly straightforward. Let's jump through the rest of these. by simply providing their implementation right there. Let's move this to its own file. It's an important enough class. It deserves a file of its own. And build that. We can now refactor our about Claymore, in fact. So instead of simply being an iView, we can treat this as if it was an example of what you could generate if you had a templating system that parsed a file and generated code. With a base class of Claymore view, actually, let's just autocomplete this. We have an execute. And the other thing that the base class is going to need is a convenient way of writing out HTML. So there's execute, and then there is write. Any value type. And that will go out through the view context. .writer, .write. The two kinds of output that you'll typically encounter are things which are output expressions, which contain user data, user values, strings, and also the results of calling HTML helpers like partial. Those all go through the write function. The other type of thing that ends up going to output are literals. When you have something which is pure HTML or should be treated as pure HTML, and that'll be output as a string. There is a reason to have two different ways of writing output. It's something that I believe it's built into Razor. Anytime you output, it automatically encodes. It was also retrofit into the web forms view engine, and it's an option. I don't know if it's the default in the Spark view engine. There's many of them that auto-encode inside of web forms, for example, the new syntax. Lets you output things, and it will always do the right thing. If you output an HTML helper, like partial or text box, it will not auto-encode that because it knows it's already an iHTML string. It knows it's material that should be treated as HTML, and it is safe to put out to the user. Everything else, if you have a string with HTML in it, will be encoded automatically. OK, well, long story short, to make that happen, put HTML encode around the value. This method on the HTML helper will look at the value and will automatically encode everything that is not meant to contain HTML. Now, back in our about Claymore, we can call write literal on some literal HTML and call a few other things that you would typically find inside of a view. A use of a label helper, Alt-Enter. Not write literal, write. So this is literal HTML. This is the kind of thing you get from a user output expression in the template. Write HTML, text box, foo. So we're assuming a foo property in our model. OK. And hitting refresh. That is just going to, I don't know why that's happening. That's going to bother me every time it happens. But never mind that. Ignore the exception behind the curtain. Here is what is coming out of our refactored about Claymore. And here are the HTML helper calls. So we have added an HTML property. We are accessing it directly. And it is passing through the HTML encode without getting automatically protected. On the other hand, if you did write out something that had a sort of like an attack, if somebody put cross-site scripting into your database, and it came out through a database field as a write statement. Oh, I have to hit compile because it's in an assembly. And then we get the exception that's bothering me. You can see that this was auto-encoded, but the text box was not. Excuse me? I don't know. That could be. That could be entirely possible. Yeah, that might be. So, Claymore View Engine. Oh, you're absolutely right. So the way that store is implemented is the key is being added and the function is being added and then invoked and returned. So it's kind of like a one-step store, execute, and give me the result. And you're absolutely right. I should have a return on that store right here. So that's what it was doing. It was storing it and then passing through to the error condition. All right. All it takes is 100 people looking at the screen and bugs just disappear. Okay. Well, I didn't finish my little line there. Hello, TechEd, as our model. Oh, I'm passing that on the hello, not the about Claymore. There we go. So you can see that we're working. The view context is passing in, the view data dictionary is populated, and the HTML helpers are connected to your view data as appropriate in context. Jumping over to our Claymore view, the other thing that is present on the HTML helpers is a version of the HTML helper which has a T model attached to it. This is not a simple string object dictionary. This is where there is a class in the assembly that represents the model. And as a result of that, the HTML helper has many more extension methods that are available, like textbox4, editor4, because those lambdas are based on the T model of the HTML helper. For that to work, we need a version of the Claymore view that has a T model on it. And we'll do that in a derived type, like this. And we have this class fully implemented, so we'll just take a look at that here. So the differences are the view data, the HTML, and the AJAX are all properties that are returning the same base value. So they're returning the same base value, but they're typecasting it to this version of that class that has the strong model on it. So when your base class has a T model, these properties are also seen with that T model. Now you can't just typecast them. When they're created, they must be created with that T model. To make that happen, we override our contextualize. This is why contextualize was virtual in the first place. In the case that we are a strongly typed model, in the case that we are a strongly typed view, we are going to create the strongly typed helpers and assign them to the base properties. So The base properties work the same from just a plain class standpoint, but from a strongly typed HTML helper standpoint, they're safe to downcast because they've been created with the right T model. All right. Well, we can take a look at an example of that later, that usage, but you can imagine what that would be. It would essentially be if we generated the class that had, an about view model on it. But I think for right now, that's enough about the base view class. Because the base view class, although it's interesting, is really about enabling your template to have code in it. Because if you don't have code, you're essentially a static file. If you don't have code, you might as well be data. Like our Markdown example, there's nothing you can do in there. You're going to want to have some way to control execution, so you can do things conditionally with loops, where you can place output statements. And this is where the view engines really start to differentiate themselves, where they start to have an opinion about what is an interesting or effective way of mixing the code and the HTML in a seamless fashion, and possibly by providing additional shortcuts, additional syntax tricks that make less typing give you better output and more output. They're all about productivity. DSLs are basically about productivity because everything you can do in a view, you could have written a class for. You just would never get anything done. So, jumping into what is essentially the final demo of the presentation, we're going to create, in addition to the Markdown extension we have, we're going to create a brand new extension and put code in there. We're going to parse it and generate a subclass of our Claymore view. Returning to our view engine, this will live in a class, again, originally called compiler. So this is separating the concern. The view engine doesn't know how to compile. We're going to delegate that responsibility to this class. And it's written in a similar pattern to the file system, with a simple function on top. Given a string, which is the contents of a file, we are going to parse, generate, and compile that text into a creatable type. This view engine fits into a single file, and it's for the purpose of demonstration, so it's kind of brute force. It's basically doing, index of, using a scan to go through the text, index by index, going further. So we don't need to look at this. It's pretty awful. The compile, on the other hand, is kind of interesting. So when you call parse and generate, it's going to fill in this string builder. So this is the input, and this is the output. It's going to write to this string builder. That is essentially C# code, and we're going to say compile source by using the code DOM provider to create a wrapper of the C# compiler. It'll fork off the CSC exe. And you can say compile assembly from source. And the results will tell you if there were errors, or if you succeeded, it will give you the assembly that you can grab your type from. The type that comes out of the assembly basically are whatever public classes you put into your source code that you had to compile. It's pretty straightforward. Let's wire this into Claymore now. So we will give ourselves some new set of possible locations. Again, if you were implementing this for real, we're going to provide this code as sample for you to download. I'm thinking of actually putting it as a NuGet package so that you can say, just grab the code into local project. But this is the type of thing that you would implement in a way that is more appropriate for your business domain. It's a great place where you can make decisions about how to, for example, based on the current request, use mobile versions of stuff. Oh yeah, I think that Hanselman had an example of that too. Internationalization is something else you can do based on something from the current context. Something like a language token or the current user's preferred language. You can even add options which have directories for languages in there. So this is, if you're writing a view engine, a place where you can take a lot of liberties and provide a lot of new capabilities as well. But that said, let's iterate over the locations that we've provided. Announce the fact that we are searching there. Basically, get text about the same way. But if we have text, this is where the difference comes in, because we are going to turn to our compiler and ask it to build this for us, giving it the text. And if it succeeds, it should return a view result, or a view type, which we can store with a return statement. So we're going to store this, and every time we see this request afterwards with matching differentiating values, key contains everything that'll make this result differ. So every time we see this with identical differentiating values, we're going to create a new instance of this type. Activator, create instance of the view type. And the only ingredient missing is a typecast. All right? So the really interesting thing is the efficiency of the cache at this point, because the key, once it comes in, will jump right here. This type is a closure variable. So we're not going to reparse anything, recompute anything. It's just a foregone conclusion. We're going to create an instance of this type and return it. All right, so we've compiled, and let's render a partial called foo. Okay, so we can see that Claymore is in effect. It's providing all of these search locations that we've added so far. Foo.claymore is now an option. And let's add a new text file at that location. Whoops. And paragraph. In fact, let's put it at the top so it's easier to see. Okay, and the output has come out. We did have a small degree of recognition for writing output. And you see that the output has changed without resetting the app domain. or rebuilding or recompiling. Because it saw the file changed, it went through and compiled a new assembly for that type. But this basically, and we can add a syntax error in order to see a nice error message with our source code. This is essentially what it's doing, is what we did with the about Claymore file. We have a base of a Claymore view. It's a compiled view, execute with write literal and write statements. So that is about all there is to it. We can take a look at putting a strongly typed model in our view here, because the compiler that we implemented does understand how to put a strongly typed model in place. Claymore demo, views, home, foo model. With a few properties. And the reason you do that is so that you have access to the HTML helpers. Label for model such that model's name property syntax error. Yep. Claymore demo views home. Isn't that curious? And we see the error here. In our simplified generation of code, we don't have the using statements in by default. We do understand a using keyword. But again, this view engine is for demo purposes. We can see where that's implemented basically by brute force. We're looking for the word using and an end of line. Subsequent using end of line, the word model end of line, and everything else is going to be looking for alligator clips. So this is the entire view engine running end to end. It's generating code. It has a DSL, which is, just for purpose of illustration about what's possible. And it has all of the fundamentals of MVC available to it. It has the HTML helpers with the extension methods, strongly typed base view class, all of the basics. It is correctly implemented in that if you have foo Claymore and foo.cshtml, it will use the one that's appropriate based on the order that they're registered. So we have essentially gained all the knowledge that we need to correctly implement a third-party view engine, or to add APIs to your system, which are not even based on files. If you want to create a view engine that's exposing an API and rendering HTML through whichever means you feel is necessary, that doesn't involve parsing and generating classes from files, that's possible as well. All of the third-party engines work this way, so do the built-in ones, and you now have all of the tools that you need to make that happen. So I suppose we can take a break here for questions. or if there are none, I could regale you with anecdotes, but that is all of the demos we have for today. Thank you.